Hey everyone, Linus here. Welcome back to another deep dive into the fascinating world of technology. Today, we're diving into the heart of your computer, the CPU, or Central Processing Unit. It's the brain of the operation, calling all the shots and making sure everything runs smoothly. You know, telling everything what to do, from running your operating system to executing software commands, from simple tasks like opening a file to complex stuff like rendering three-dimensional graphics. The CPU handles it all with precision. Without the CPU, your computer would just be a lifeless box, unable to perform any functions. It's the CPU that breathes life into it, making it possible for you to browse the web, watch videos, and play games. Pretty cool, right? Imagine trying to do all that without a CPU. Now you might be thinking, CPUs sound complicated. And you're not wrong. They are intricate pieces of technology. But don't worry, they're not as scary as they seem. Once you understand the basics, it all starts to make sense. In this essay, we'll break down everything you need to know about CPUs in a way that's easy to understand, even if you're not a tech expert. Think of it as a crash course on your computer's most important component. By the end, you'll have a newfound appreciation for the tiny chip that makes it all possible. Alright, let's pop the hood and see what's inside a CPU. This tiny yet powerful component is the brain of your computer, handling all the instructions it receives. Don't worry, we won't get too technical here. We'll keep things simple and easy to understand. At its core, a CPU is a tiny chip packed with billions of transistors. These transistors are microscopic, yet they play a crucial role in the functioning of your computer. Think of transistors like tiny switches that can be turned on or off to represent data. Each switch can either be in an on state or an off state, corresponding to the binary code that computers use. These transistors work together to process instructions and perform calculations. They are constantly switching on and off at incredible speeds, allowing your computer to perform complex tasks in mere milliseconds. It's like a massive network of switches flipping on and off to make your computer work. Pretty neat, huh? This intricate dance of transistors is what powers everything from simple calculations to advanced graphics rendering. Now, CPUs have a few key parts that work together seamlessly. Each part has a specific role, and they all collaborate to ensure your computer runs smoothly. We've got the arithmetic logic unit, the control unit, and registers. The arithmetic logic unit, or ALU, handles all the mathematical operations and logical decisions. Don't worry, we'll explain what each of these does in the next few sections. The control unit directs the operations of the processor, while the registers store data temporarily for quick access. But for now, just remember that these components are like specialized teams within the CPU, each with its own important job to do. Together, they make sure your computer can handle everything you throw at it, from browsing the web to playing video games. Now, you might be wondering how the CPU actually processes instructions. Well, it follows a simple three-step process: fetch, decode, and execute. It's like a dance that the CPU performs millions, even billions of times per second. First up, we have the fetch step. Here, the CPU retrieves an instruction from the computer's memory. Think of it like grabbing a recipe from a cookbook. Next comes the decode step. In this step, the CPU figures out what the instruction means. It's like reading the recipe and understanding the ingredients and steps involved. Finally, we have the execute step. This is where the CPU actually carries out the instruction. It's like following the recipe and baking the cake. Let's talk about the ALU, or arithmetic logic unit. This part of the CPU is like a math whiz. It's responsible for performing all the arithmetic and logical operations that your computer needs to do. When you're adding numbers in a spreadsheet, the ALU is hard at work. When you're comparing two values, guess what? The ALU is on the case. It's the number cruncher of the CPU, handling all the calculations with lightning speed. But the ALU doesn't just do math, it also handles logical operations like AND, OR, and NOT. These operations are used to make decisions and control the flow of information within the CPU. So next time you're crunching numbers or making logical comparisons, give a shout out to the ALU. Section 5, the control unit, the CPU's conductor. Now let's meet the control unit, or CU. This part of the CPU is like the conductor of an orchestra. It's responsible for controlling and coordinating all the other parts of the CPU. The CU fetches instructions from memory, decodes them, and then tells the other components what to do. It's like the boss of the CPU, making sure everything runs smoothly. Without the CPU would be a chaotic mess. It's the CU that keeps everything in sync, ensuring that instructions are executed in the correct order, and that data is sent to the right places. So think of the CU as the brains behind the operation, making sure everything works together in perfect harmony. Section 6, registers, tiny memory champions. Alright, let's talk about registers. These are like tiny, super fast memory locations within the CPU. Think of them like the CPU's personal scratch pad, where it can store data that it needs to access quickly. Registers are much faster to access than the computer's main memory, or RAM. That's because they're located directly on the CPU chip itself. This makes them ideal for storing frequently used data and instructions. When the CPU needs to perform a calculation, it can load the data from RAM into its registers. This speeds up the process because the CPU doesn't have to wait for the data to be fetched from RAM every time it needs it. So, registers are like the CPU's secret weapon, helping it to process information with lightning speed. Section 7, cores and threads, powering through tasks. Let's dive into the fascinating world of cores and threads, the unsung heroes of modern computing. These components are like extra helpers that allow the CPU to handle multiple tasks simultaneously, making your computer more efficient and powerful. Imagine it's like having multiple chefs in a kitchen, each working on a different dish. The more chefs you have, the more dishes you can prepare at the same time. A CPU core is essentially an independent processing unit within the CPU. Think of it as a chef with their own set of tools and ingredients. Each core has its own arithmetic logic unit, ALU, control unit, CU, and registers, allowing it to execute instructions independently and efficiently. A CPU thread, on the other hand, is a single sequence of instructions that a core can process. It's like a recipe that the chef follows. A single core can actually handle multiple threads at once by switching between them very quickly. This technique is known as multi-threading, and it significantly boosts performance. Having multiple cores and threads allows the CPU to be much more efficient, especially when running demanding applications like video editing software, high-end video games, or complex simulations. So, the more cores and threads your CPU has, the better it will be at handling multitasking and demanding workloads. This is why modern CPUs are designed with multiple cores and threads to keep up with the increasing demands of today's software and applications. Upgrading to a CPU with more cores and threads can significantly improve your computer's performance, making it faster and more responsive. Whether you're a gamer, a video editor, or just someone who likes to have multiple applications open at once, a powerful CPU can make all the difference. Section 8, clock speed, setting the pace. Now let's talk about clock speed. This is a measure of how many cycles per second the CPU can execute. It's like the CPU's heartbeat, setting the pace for how quickly it can process information. Clock speed is measured in gigahertz, or GHz, with higher numbers indicating faster speeds. A CPU with a clock speed of 4 GHz can execute 4 billion cycles per second. Generally speaking, a higher clock speed means better performance, especially for tasks that require a lot of calculations, like gaming or video editing. However, clock speed isn't the only factor that determines CPU performance. The number of cores and threads, as well as the architecture of the CPU, also play a significant role. Section 9, different CPUs for different jobs. Just like there are different tools for different jobs, there are different CPUs designed for different purposes. Let's take a look at some of the most common types of CPUs. These are the workhorses of the PC world, designed for general-purpose computing tasks like browsing the web, watching videos, and running office applications. These are designed for use in laptops and mobile devices. They're typically smaller and more power-efficient than desktop CPUs. These are designed for use in servers, which are powerful computers that provide services to other computers over a network. Server CPUs are built for reliability and performance under heavy workloads. Each type of CPU has its own strengths and weaknesses, so it's important to choose the right one for your needs. Section 10. Picking your perfect CPU. Choosing the right CPU can seem daunting, but it doesn't have to be. Here are a few things to keep in mind when selecting a CPU. What do you plan on using your computer for? If you're mainly browsing the web and checking email, you won't need a top-of-the-line CPU. But if you're a gamer or video editor, you'll need something more powerful. CPUs can range in price from a few $100s to over $1,000. Set a budget before you start shopping so you don't overspend. Make sure the CPU you choose is compatible with your motherboard. Not all CPUs are compatible with all motherboards. Section 11. Keep exploring the world of CPUs. That's it for our crash course on CPUs. We've covered a lot of ground, but there's always more to learn. If you're interested in diving deeper into the world of CPUs, there are tons of resources available online and in libraries. Just remember, the CPU is the brain of your computer. Understanding how it works can help you get the most out of your computing experience. So keep exploring, keep learning, and most importantly, have fun with technology.